Hey guys, let's look at number 17 and number 26 on section 4.2. This is still the section where we're doing the closed interval test. So all we're doing in order to find the high and the low values, the minimum and maximum values of the function, are we say that those values occur at either endpoints or at any critical point within the endpoints. So in number 17, where we have the rational function x squared plus 2 over x minus 8, first step is to take the derivative using the quotient rule, denominator times the derivative of the numerator minus the numerator times the derivative of the denominator gives me the x minus 8 times 2x minus the group x squared plus 2 times the derivative of the denominator 1. Now, whenever I simplify that out, I can see that the only terms that can ever make that fraction equal 0 are the numerator. The denominator is irrelevant here. It can't make the fraction equal 0. So I simplify the numerator, distribute the 2x through the first group, and I get 2x squared minus 16x, and then I have minus x squared minus 2. The 2x squared minus x squared gives me 1x squared. Then I have the minus 16x minus 2. I quickly saw that that was not going to be easily factorable to set equal to 0. So then I just used the quadratic formula and said, well, it's going to be positive 16 plus or minus the square root of 16 squared minus 4 times a times c, which gives me plus 8. So inside that square root, I have a 264. And then all of that's divided by 2 times a, which is obviously 2. Now that square root of 264, I went ahead and said, well, that's nothing more than 4 times 66. And then the square root of 4 comes out as a 2. So I have square root of 264 simplified to 2 on the root of 66. Now I see that this 2 in the denominator can distribute into both terms in the numerator. And this critical point simplifies to be 8 plus or minus the root of 66. But now the depressing part of this problem is neither of those critical points that we just worked so hard to find are within the region of the problem. This problem stipulated that it wanted your values of x to be between 9 and 10. So we say, well, okay, neither one of these are going to be between 9 and 10. So they're both irrelevant for this problem. So we say neither critical point is in the region. So for your extreme value theorem, you just say any maximum or minimum only occurs at the endpoints. So I just plug the 9 and the 10 into the original function. When you plug a 9 in, you'll get 81 plus 2, which is 83 over your denominator of 9 minus 8, 1. You get an 83 at that value. When you plug in the 10, it's easy. It's just going to be 102 over 2. That gives you a 51. So in this problem, pretty quickly and easily, we can see the minimum is 51 and our maximum is 83. We check that and it says correct. Now the last problem in this section, number 26, I like it better. It has us working with Rawls Theorem. If you remember what Rawls Theorem says, it just says that if your function begins and ends at the exact same y value, then the derivative has to be equal to 0 for some x value in between those. So the function we're asked to verify Rawls theorem for in this problem is, again, a rational function, x squared over 5x minus 4. First, I went ahead and evaluated the function at the endpoints this problem stipulated, 1 and 4, just to make sure, yes, it's beginning and ending at the exact same y value, and it is. If you plug a 1 into this function, you get a 1. You plug a 4 into it, you get a 1. So since the function is beginning and ending at the exact same y value, then the derivative better be equal 0 for some x value in between 1 and 4. That's what Rawls theorem tells you. So whenever I took the derivative, I'll say, well, again, I squared the denominator, bring that denominator to the numerator times the derivative of the numerator, minus the numerator times the derivative of the denominator, 5. This would have given me 10x to the second minus 5x to the second for a total of 5x to the second. And then minus 8x there, the negative 4 times 2x for minus 8x. Again, I know the only way that a derivative can equal 0 when it's a fraction, it's only the numerator. Completely ignore the denominator every time. It's irrelevant. So you just say, well, okay, my critical points are when the numerator is equal to 0. I can easily factor that expression and say that's going to be an x times a 5x minus 8. And then so my critical points are going to be when x is equal to 0 and when 5x minus 8 is equal to 0. This gives me 5x equals 8 and x is equal to 8 over 5. Now, the only critical point that's relevant to this problem, because again, we were trying to verify Rawls theorem to show that there must be a critical point between 1 and 4. Well, there is. It's not 0 because that's not in there, even though 0 is a critical point. The critical point that we were guaranteed to have between 1 and 4 is at 8 over 5, which is 1.6. So back in my problem here, submit any values as a comma separated list. Do not round. Well, we don't have to do that because there's only one value. I'll do the fractional value of 8/5, and we'll check that out here. And it's saying correct. Okay, guys, hope this helps you with these two problems in 4.2. Let me know if you have any other questions.